Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture I am going to explain problems on esterification reaction. Before solving problem, I will explain some important points on this reaction. In esterification reaction, carboxylic acid is treated with alcohol in presence of concentrated sulfuric acid to form ester and water. Now see, this is reversible reaction. Forward reaction is called esterification and reverse reaction is called ester hydrolysis. Here catalyst is concentrated sulfuric acid and we know it is also dehydrating agent. So it absorbs water and reaction proceeds in the forward direction. So we have seen concentrated sulfuric acid is catalyst and at the same time it is dehydrating agent. Now mechanism. Now see, this H plus we are getting from concentrated sulfuric acid. Here lone pair of oxygen will be donated to H plus and we will get protonated carboxylic acid. After that what will happen? Alcohol is there. So this bond will break to neutralize this positive charge and lone pair of oxygen will be donated to this electron deficient carbonyl carbon. Here we will get R, C, OH, OH. In alcohol part we will get this plus. After that proton transfer will take place from here to here. Oxygen lone pair will be donated to H plus and we will get R, C, OH, here OH2 plus and here this. So intramolecular proton transfer is taking place. Removal of water will take place. At the same time this will be donated here. So we will get R, C, double bond OH plus and here OR prime. Then this H plus will be eliminated and we will get R, C, double bonded O, OR prime. Means this is our ester. So what is happening? We are getting ester, removal of water is taking place and we are getting back H plus. So it is catalyst. After the reaction we are getting back this one. So what you have to do, if you observe the mechanism, you will understand that from carboxylic acid RCO part is here and from alcohol R prime O is there. So from here removal of OH and from here removal of H is taking place. And see, this step is slowest step. So this is rate determining step. Now in the substrate, see this carbon is sp2 hybridized. Means here bond angle is 120 degree. Now after the rate determining step, we are getting here sp3 hybridized carbon means tetrahedral carbon. Here bond angle is around 109 degree 28 minute. So steric crowding is increasing. So if there is steric crowding here in the carboxylic acid part or in the alcohol part, reaction rate will be slow due to steric reason. So we can say reactivity is inversely proportional to steric crowding in the acid part or in the alcohol part. Means with increasing steric crowding, reactivity will decrease. So if acid is same, then reactivity will depend on alcohol part. So see, steric crowding is increasing in this direction, so reactivity is decreasing in this direction. So methanol is highly reactive. After that 1 degree, then 2 degree, then 3 degree. In this direction reactivity is decreasing since steric crowding is increasing. At the same time, if alcohol is same, then reactivity for esterification depends on steric crowding in the carboxylic acid part. With increasing steric crowding here, see reactivity will decrease. So in short, what we have seen in ester formation reaction, this bond is breaking and this bond is breaking. So removal of water is taking place and we are getting ester and water. So this RCO group is called acyl group. So which bond is breaking in the carboxylic acid? Acyl. This is acyl group, RCO and oxygen. So acyl oxygen bond is breaking here and here this OH bond is breaking. Now write down products for this reaction. So what we are using here? Normal oxygen is having atomic mass 16. Here we are using oxygen 18, means labeled oxygen we are using. So from acid part OH will go and form with alcohol H will go. So what we will get? Water and CH3, C double bond O, C2H5, and this O is coming from alcohol, so it is labeled, means it is isotope of oxygen. So here that O18 oxygen will come. Now suppose you are having C6H5, C double bond OOH plus ethanol. Concentrated H plus we are using. So here we are using labeled oxygen O18 isotope. So here what will happen? OH will go from here, carboxylic acid, and H will go from here. So by removal of this part we will get C6H5, C double bond O, OC2H5, and in water that oxygen 18 is there because this OH and this H is forming water. Next problem, what's the product here? Here we are using that labeled oxygen. So here in the same molecule carboxylic acid and OH is there. So if situation is like that and if by removal of water will give a 5 or 6 membered ring compound, then that will form. So you can write this structure CH2 OH, and here how many CH2s? 1, 2, 3 CH2s are there. Then here what is there? O18H. So what will happen? By an intramolecular esterification reaction, it is called electronegativity. By removal of water, OH from here, H from here, we will get CH2, 3 CH2s are there, then here one oxygen, and this oxygen will be bonded to carbon. So this is O18. This product, this is called, with respect to this carboxylic acid, this is alpha, this is beta, this is gamma. At gamma position with respect to this COH, at gamma position OH group is there. By removal of water we will get gamma lactone. This 5-membered ring lactone. So 5-membered ring stable ring, we are getting this compound. Next problem, you are having oxalic acid and this vicinal diol in presence of concentrated sulfuric acid or in presence of H plus. What is the product? So this is acid, this is alcohol. So esterification in presence of acid will take place, and what we will get? From here OH will go, from here H, from here OH, from here H. So see what product we will get? C double bond O, it is bonded with C double bond O, then it is bonded with oxygen, it will be also bonded with this carbon, will be bonded with oxygen. Then here CH2 is there, here also CH2 is there, plus 2 molecules of water, because you can draw this structure OH, C double bond OH plus CH2, CH2, OH, OH. So OH will go from here, H will go from here, OH will go, H will go. So C double bond O, O, C double bond O, O, and this part. We are getting this thing. Now see, in this alcohol, two types of OH groups are there. This OH is bonded with carbon, which is bonded with two carbon atoms. So this is secondary alcohol, and this OH is bonded to a carbon which is bonded with only one carbon. So it is primary carbon. So we know reactivity of primary carbon is more than secondary carbon than tertiary carbon due to steric reason. We have seen, because here in carboxylic acid this carbon is sp2 hybridized, bond angle is 120 degree, but when it is forming the tetrahedral compound after nucleophilic addition reaction, the tetrahedral compound is having bond angle 109 degree. So with increasing steric crowding in acid part or in alcohol part, reactivity decreases. We have seen that one. So here which one is more reactive? Primary alcohol is more reactive. So what is the product? This is benzoic acid. So this OH and this H will be removed in presence of H plus, and major product will be this secondary alcohol will be as it is. Here CH2O CO C6H5. So ester C6H5 COO and this part. This ester we are getting. That is in major amount. If you like, please subscribe. Thank you for watching.